Good day, grade 11s. Today we are going to start a new topic, number patterns. This is a topic that you've covered in, I think, since grade 8. So it's nothing new. It's just this year we are just going to add one type of number patterns that you haven't explored in the previous years. Okay. Before we carry on with this, we are going to do in book 1 because it is going to be in your paper 1. Okay, so please make sure that you write the notes on the correct book. Okay, we'll first do a recap on the types of number patterns that we have. We've got the linear number pattern, which is sometimes called the arithmetic number pattern. Okay, I'll just refer to it as a linear number pattern, but in some other books you'll find it written like that. Okay, so a linear number pattern is a number pattern where you add the same number. So we are looking at a relationship where you are given a list of numbers. So in this type of number pattern, you add or subtract the same number throughout, and that number that you keep on adding throughout, we call it the constant difference. So I've got a number pattern here which is 3, 5, 7, 9, and it carries on. So carries on we indicate by 3 dots like that. Okay, so it's 3, 5, 7, 9. Right, so we want to look at the relationship here if it is linear. So if you look here, if I move from 3 to 5, I have to add 2. If I move from 5 to 7, I have to add 2. So a description in words of this type of number pattern would be an add 2 type of pattern. So each time to move from one term to the next, you have to just add 2. Okay, and then if I were to ask you to write the next two terms, you just carry this on for and then you write the next two numbers. So 9 plus 2 will give you 11, 11 plus 2 will give you 13. I'm sure you know this by now. And then we also can find now the general term, which we call the nth term. And the nth term is the equation that we use to find a term that can be anywhere in this. As you can see, 3 is term number 1, 5 is term number 2, 7 is term number 3. Now with the general term, I can use it to find term number 25. So that means I will not have to now write 25 terms for me to get there, or term number 50, or like keep on adding 50 times until I get to what I'm looking for. So instead of listing the terms, you can just use the general formula, which is the nth term, Tn, the nth term, Tn, to find the equation. Okay, to find the term. So how do we write Tn? Tn, the general equation for that is a constant difference times n plus T0. Now what is the constant difference? It is that number that you use to move from term 1 to the next. Okay, so this is how the constant difference is calculated. It's term 2 minus term 1, or you can say term 4 minus term 3. So here I've just written it's next minus previous, so it's this one minus that one, or this one minus that one, or front minus back, depending on what you understand best. So it could also be 9 minus 7. So it's always the front one minus the back one. Okay. Right, so that's the constant difference. N stands for the position. So like here, N would be 2 because this is in position number 2. Okay, and then T0 is the term before term 1. Okay, so in this case, you can see term 1 is 3. Okay, And then to find term 0, which is this one that I've written in a block, this one is your term 0. Okay, this is T0. Okay, so how do I get T0? Okay, as you can see, moving forward, I was adding 2. So you do the reverse of this one, or the inverse operation of this one. So if I add 2 going forward, it means I'm going to subtract 2. So 3 minus 2 will give me 1. So that means term 0 is going to be negative 2. It is going to be 1. 3 minus 2 is going to be 1. So my term 0 is going to be 1. Okay. So that means the equation for finding any term that lies or that belongs to this number pattern would be determined by this equation. Tn is equals to 2n plus 1. 2n plus 1, which is what I've written here. Right. And then we can now find term number 20 without having to list 20 terms. Find term 20. So you write T20. So in the place of n, I've written 20. So that means also in the place of n here, I'm going to replace that with 20. Please do your substitution in brackets. So it is 2 times 20 plus 1. And we mark the formula, we mark the substitution, and then we mark the answer. So if you're just going to move from the formula to the answer, then you lose this mark for a substitution. So please always show the steps, the substitution. Right? Sometimes you can be asked to find like the position of a given term. So the question would be, which term is equals to 121? So 121 is a number that will appear somewhere on this list. So we want to find out that what a term or what position is occupied by this number 121. So that means we have to work backwards with the formula that we have. So all you do is in the place of Tn, you write your 121, and then we are looking for n. So you are going to work backwards to solve for n. So you subtract 1, okay? Subtract 1, and then you divide by 2. So 121 minus 1 is 120, and then you divide by 2. So you just solve for n in this equation. You substitute here 121 in the place of Tn, and then this is equal to 2n plus 1. Then you solve for n. So n comes out as 60. Then you must answer the question because it said which term. So you must say it is term 60, or it's the 60th term, or you can say T60 is equals to 121. Don't just end here by n equals to 60. You have to answer the question. Sometimes this is your the work that you will do. I just want to highlight that sometimes the equation can be given, and then you can be asked to find T15 or T7 in the given equation. So that means this equation has already been established for you. So all you do is just substitute. So in the place of n, you put 15. So again, in the place of n here in a bracket, you put 15, and then it means T15 is going to be negative 74. And then again, T7 is going to be negative 34. And as you can see, these terms are negative. So that means the terms, the numbers that can be in a number pattern, can either be whole numbers, they can be negative numbers, they can be fractions, can be decimals, as long as there is a constant difference between them, then you can have a linear number pattern. So it doesn't necessarily have to be whole numbers like this one. You can get fractions. So remember, the constant difference is the front minus the back one. Front minus back, then you get your constant difference. So even if it's a fraction, you'll still get it's a quarter minus a half, then you get your answer. Right, so please do exercise 1. number 1, 3, 5, and 6 on page 55 of your textbook, 54 and 55 of your textbook. Thank you.